Yeah, it started. Yeah.
All right. Okay. Thank you. And good evening. And I hope everybody is keeping safe and sound. So let's try to get into the slide or the presentation. Let me just share my screen as usual. And based on your request, today we are going to do a bit of a, I would say, a bit of a deep dive on the instance recovery. Um, So let's try to understand few things before we enter into our main topic. There are various things that we have to fundamentally understand before talking about instance recovery. Few things we have already discussed, but there are few additional to what we have already discussed as well. Starting off with the redo thread. So we have learned about redo logs. So it's whenever you say redo thread, so it's actually we are referring to a redo log, but it's actually a stream of changes that are coming in, which we call a redo thread. Obviously, this stream of information or stream of tracking, uh, you know, changes, they're all recorded in redo log files. That is true, but as a whole, we call it a redo thread. So maybe I think last time or maybe the one before, I would have explained slightly on a thread as well. So when you take an instance, so instance is the database instance that we are talking about. The instance will be attached with a redo thread, streams of a stream of redo entries. Okay, and that is what you call a thread. So if you're talking about a single instance database, you will have a single thread, a redo thread available. Similarly, if you have multiple instances, let's say we are going with a clustered environment or clustered database, which we call real application clusters, each host will have its own instance to manage the database, and each instance will be attached to a single streams of redo. Okay, so that is what you call redo thread. Okay, so here, if you're talking about a single instance databases, we are talking about a single redo thread. Okay, so whenever changes are occurring at the database level, here, whenever I say changes happening, the changes will happen at the block level, the database block level. We discussed that before. Changes are happening. What changes are happening, and what exactly the change that is occurring, and what was the before value, and how would the information or piece of information that is required for that transaction to be rebuilt or reconstruct. That is what is being stored inside these redo streams. All right. So that will ensure that in the event if you have lost your transaction, since we are writing to the redo stream very fast, even if you have lost it in the memory, we should be able to recover it from the redo log files. Okay, so that is the purpose of redo. And then we also have something called as checkpoints. We have learned about checkpoints. It's a process where database gets synchronized. In other words, changes that are in the memory, the change blocks, which we call the dirty buffers. Whenever I say dirty buffers, again, try to understand dirty buffers doesn't necessarily mean that all blocks that you have changed have committed transactions. Okay, so there could be committed and uncommitted as well. So, however, writing those changes to the database to make that database consistent, right, is what you call checkpoints. Now, when you are talking about checkpoints, there are different types of checkpoints that we will come across. One is what we call a thread checkpoint. A thread checkpoint is related to the redo thread that I was talking about before, which is attached to an instance, right? So at an instance level, all the changes that are happening can also be introduced or can also be called as a database checkpoint, right? And that will make sure that whatever you have in your instance level getting flushed into the redo log files. I'm referring to the changes. Okay. Now, what are the instances where the instances where the checkpoint, thread checkpoint would occur? So when you are doing a consistent database shutdown, meaning if you do a shutdown, that means shutdown normal. If you incur shutdown transactional, if you do shutdown immediate, except for shutdown abort, right? We call it a consistent database shutdown. So whenever you do a consistent shutdown, it will make sure a thread checkpoint is occurred, or in other words, most likely it would be a database checkpoint. Whenever you do a redo log switch, okay. Whenever you do a alter system checkpoint, if you explicitly issue a checkpoint as a DBA, as a sys DBA, you want to flush your content to the disks or to the data files, then we call it a when we can explicitly call alter system checkpoint. Those days, we used to have this command called alter database begin backup in order to convert, in order to prepare our underlying data files or database or table spaces to a mode where we can start taking hot backups when the database is up and running. So although it is not very much popular right now these days, it is still available. You can use it. Okay, so these types of events will incur a thread checkpoint. Then instead of having it at a very at an instance level, checkpoints may also occur at table space or data file level. So one example is like whenever you are making a read-write table space into a read-only table space, you need to make sure whatever the pending transactions which are committed have been applied onto this table space before you make it read-only. I think it makes sense, right? So in such cases, there will be a table space checkpoint that would get occurred. And when you make a table space offline again, or maybe if you perform a shrink data file command, and even if you do the same begin backup command against a table space, right? In all these events, it will be a partial kind of a checkpoint that would occur, and that will be on table spaces or the related data files. Then we also come across incremental checkpoints, and incremental checkpoints is actually is something let's say a subpart of thread checkpoints, where now whenever you do a log switch, right? If you can recall earlier when I was talking about thread checkpoint, I was talking about a redo log switch. When Oracle writes to one redo log file, and once that redo log file is over, it gets switched to the next available redo log file. At that time also, there will be a thread checkpoint that would get occurred. But what happens is that if your redo log file is very big, right? Or if the changes are extremely big, that needs to be flushed from the buffer cache maybe to the data files. If the content is larger, then the amount of workload or amount of data that needs to be flushed from the memory to the data files would be more. So in order to tolerate that, in order to have a minimum impact, what Oracle would do is whenever it feels the right time, it will flush dirty buffers to the data files. Right? It will flush dirty buffers from the memory to the data files. Now, when I say dirty buffers, I told you earlier as well, these dirty buffers, meaning blocks or buffers having blocks that are changed, these changed blocks may not have yet been committed. So still, it may not necessary, therefore, to have a commit done on a block to be written back to the data files. Okay. So for a temporary period of time, or maybe until it gets committed, right? Oracle will try to push them from the memory to the data files. So some of the blocks will be already committed or changed to blocks. Some of the changed and committed blocks, and some of the blocks may not be yet committed. So, if you really want to check this out, maybe you can insert some records to one of your tables. And if there's a possibility of reading your data file externally, now if you're running on Linux, you can make use of the command, OS command called strings, and see the content of your data file. Okay, so since you may not have included or encrypted your content at a data file level, you will see your content in plain text. So if you run your strings command, OS command against one of those data files, sometimes sometimes you'll be able to see those changes that you have made to the database, which are not committed, but still have come into your data files. That is a normal expected behavior. Okay. So Oracle will not always wait until everything gets committed to the checkpoint. Okay. So as I was saying before, it avoids large number of dirty buffer writes during a log switch. So it will make sure the tolerable amount is limited, right? When you are doing, because whenever a log switch happens, there has to be a checkpoint that gets occurred. So when you are occurring a checkpoint, it makes sure all the dirty buffers gets written to the data files, right? So if the quantity is less, then the amount of dirty buffers to be written to the redo log files will be, sorry, not to the redo log files, but to the data files will be less at a log switch time when the checkpoint is getting occurred. So when these incremental checkpoints get occurred, right? So it will happen time to time especially when the database is idling, because this writing of dirty buffers from the buffer cache to the data files is actually a overhead. It's a resource taking activity to the database. So it will always try and see what is the right time to do this. So if you have less work happening at the database front, obviously that time will be utilized by Oracle to write this or flush these dirty buffers to the disk or to the data files, right? Again, I'm emphasizing blocks may be committed blocks you have. Sometimes you may find uncommitted blocks as well. Okay, so whenever an incremental checkpoint occurs, it updates the control file with the checkpoint position. So we'll talk about the checkpoint position a little later on. Okay, then there are some other types of checkpoints that you will come across as well. Things like instance and media recovery checkpoints. Those are very special types of checkpoints that we may need not to discuss right now in this session. And there could be checkpoints occurring when you are truncating objects, when you are dropping objects as well, right? So those would happen only at certain, not actually at the database level, right? But at certain different levels, these checkpoints would also occur. Then we also need to know about checkpoint SCN. So SCN is the system's change number. It's actually a counter that you have in the database that gets incremented by every second, right? So you can query your database with the current underscore SCN from $B database and see the current SCN. So it will get incremented by second, right? So each second the counter will go up. So checkpoint SCN basically refers to that number or the counter that basically tells you exactly at what SCN the last checkpoint has happened. Okay. Now, how would that get related to our discussion, our topic today? The moment we know what is the last position or last SCN when the checkpoint has occurred, that is the point where this instance recovery would start. Okay, because if everything has been properly written to the database, and if the database is in sync, in a proper state, right? Before that, any changes, you don't need to modify, right? We don't need to recover. But From that point onwards only, we need to see if the database is in an inconsistent state to make it consistent, right? So that is the point where our instance recovery would begin. So when the database checkpoints occur, the thread checkpoints especially, right, I'm referring to those, when that occurs, the SEN of that checkpointed, checkpointed SEN basically will get written to the control file as well as to the headers of the data files. Okay, that is something that you can remember as well. Right, then we talk about the control files. Obviously, control files, as I just mentioned before, holds checkpoint SCNs, right, in this particular activity. And then another background process, which is systems monitor. Systems monitor is completely responsible in performing the whole instance recovery process, right? It is responsible in identifying the gap, right? How it should be initiated and getting the changes, right? And also rolling back unwanted changes. They are all part of the SMON's tasks. So we'll discuss more about the full process as we go on. And then we also have the database writer. So database writer process is responsible in writing the data dirty buffers from the database cache to the data files. Undo is required. Why undo is required? Undo basically holds the before image of a block. Before a block becomes, in a buffer, the block gets changed, right? So you take the block into the buffer and the records in that block will get changed. So we call it a dirty buffer. So before a block gets changed, you need to have a before image, a previous image of the same block or a consistent copy of a block to make sure in case if you want to roll back, you have a before image available. So these before images, which we call undo segments, undo blocks, they are stored inside undo table spaces. Okay, so these are all needed for this discussion of instance recovery. Okay, now we are moving on to instance recovery. What exactly is instance recovery? Now, when the database gets shut down, right, due to various, it might get shut down purposely as well, because maybe for maintenance purpose, you may do a shutdown. So when you're doing a shutdown for a maintenance purpose, obviously you will not do shutdown abort, right? So you will do a shutdown immediate, most likely, or other shutdown levels except for shutdown abort. So when you are doing a shutdown immediate or anything safe, right? So I wouldn't call shutdown abort unsafe option. I will explain a little bit more on shutdown abort later. But if you are doing shutdown abort is not a consistent type of a shutdown command. The main reason is that if you issue a shutdown, any other shutdown option, at the end of the shutdown process, it issues explicitly a database checkpoint. So whenever a database checkpoint is issued just before the shutdown, it ensures everything that you have in your memory is consistently written to the data files. So now the database is in a consistent state. Whereas in a shutdown abort, this checkpoint will not occur. Right? This checkpoint will not occur. So therefore, it just shutdowns as is. So if that happens, when you bring up the database next time, the database will not be in a consistent state. Right? So this is one of the scenarios in order to trigger a database instance recovery. Okay. Now, so when you don't have a checkpoint occurred at the time of a database shutdown, what would happen? So this could be somewhat similar to a situation where all of a sudden your instance crashes due to a memory problem, due to a power problem, right? A running instance will crash. Okay. So now you bring the database up. Now, when you bring the database up, then the database would have had or maybe the instance, our instance would have had committed blocks in the memory that had not got updated in your data files. So definitely that is going to be a problem, because whenever you do a commit, you send the commit message to the user saying that this has been permanently recorded, but still your blocks, your dirty buffers are still in memory and they have got lost because of a power failure. Now they are not updated in the data files. So when you read the database next time, you don't find those changes, right? So that is going to be a big issue. Okay, so that is where the instance recovery will come into play. So instance recovery will ensure that all these changes that you have to apply to the database had been applied through the redo stream. So the redos will be read in order to reconstruct the lost transactions, and that will be applied to the database as if somebody is doing the change. And then that will be applied properly. And that is the whole purpose of an instance recovery. Sometimes we call it a crash recovery. Why? Because this could have happened due to a unexpected scenario. Now I told you shutdown abort is an explicit command that we issue. Maybe with a purpose we did that. Right? So at the same time, this would have happened due to a power failure. So that is something, I mean, it's a crash, right? So therefore, we do a crash recovery. And so we call it instance recovery, we call it crash recovery. Either way, we are referring to this instance recovery. Now, what is the whole purpose of an instance recovery? To make sure when the database is up for the users, right? When they become available for when the database become available for the users after the restart, we need to make sure that all what they have committed are properly there in the database. Right? All unwanted ones are not available in the database. Because as you can remember, I mean, as you can understand, while the database is in progress, there could be blocks that are getting changed. We call it the in-flight transactions. In-flight means the changes are currently happening on the blocks. Maybe those blocks are to be updated or committed in the next 2-3 minutes. But before that, if something goes wrong, those changes cannot be considered permanent because the commit was not given at the time of the failure. Okay, so those have to be ignored, taken off, and those have to be, we call it rollback, right? So we have to do a rollback on those blocks as well. So when you are doing the instance recovery, primarily we make use of the redo log. I told you the redo streams or redo thread will be used in order to read those and retrieve whatever needed for whatever the information or the tracking information needed in order to reconstruct the transaction. How would the instance recovery be triggered? How would Oracle know that there is a need of a instance recovery? That is an important thing. First of all, the database has to have an instance failure. So this instance failure is what we call a crash. Or you would have done an inconsistent shutdown. So when I say inconsistent shutdown, that means shutdown abort. Why I say that? I told you earlier as well. If it is a consistent shutdown, at the end of the shutdown process, you have to, I mean, it's a must to issue a database checkpoint. So if the moment you do a shutdown, what you call database checkpoint, it ensures that the database is in a consistent state. So next time when you start your database, you don't need to worry that everything is in a proper state. But if you do a shutdown abort, that last checkpoint is not going to occur. So why it is not occurring? Because that's the fastest way of shutting down the database. So if you are in a hurry, you can't waste time, shut down abort, or maybe it is hanging or something like that, you can do shutdown abort. So without a checkpoint, it will shut down the database fast. So that's the whole purpose of shutdown abort. So that's a available command in the database. Right. So some people have a misinterpretation that when you issue shutdown abort, that is going to hurt the database. Not exactly. It's a given command, so Oracle will not give you commands to damage their database, right? But you have to understand it is going to be an inconsistent shutdown because of the not having a checkpoint at the end of the shutdown command. Okay. Now, one thing is to, here we are talking about how the instance recovery requirement is detected. So one condition is, of course, it has to be a inconsistent shutdown. So the other thing is, always remember when you open a database with read-write option. Why I am explicitly saying a read-write option? Because if it is a read-only option, there are no changes happening at the database level, right? Then there is nothing to recover, right? If it is read only, then there's nothing to be checkpointed. Nothing is going to get changed, right? Here I'm referring to read write. So whenever you do a read write open for your database, right, it basically opens what you call the redo threads, right? So the redo threads will be open, will be marked as open, and that will be updated in the control file. And when you do a consistent shutdown, at the end of this shutdown process, the control file will be updated saying, now the redo stream is going to be closed, right? But if it is an inconsistent shutdown, such as a shutdown abort or a failure, instance failure, this entry of making the redo threads closed updated in the control file is not going to occur, not going to happen. Okay. So that means when you are starting the database, Oracle will get to know that there had been redo stream is there, but there is no active instance, right, for those redo threads. So it had been opened before, but not closed properly. So that indication will trigger the instance recovery. So there are two things to satisfy. One, obviously you have to do an inconsistent shutdown or a crash, right? Oh, plus you need to, plus Oracle will also detect this through redo threads not getting closed properly at the time of the shutdown. There are phases of instance recovery. Right? Phase one is what you call roll forward. Now, what do you mean by roll forward? Okay, so once, if you can remember, I told you about a checkpointed SCN. Okay, when you bring up your database after a instance failure or a shutdown abort, let's just call it after an inconsistent shutdown. When you bring it up, right, the last checkpointed SCN is recorded in the redo log files. Database checkpoint, remember, goes into the control file as well, right? So once Oracle has detected that there is, we understood that triggering points of instance recovery. Once it has recognized an instance recovery is required, Oracle needs to know for how long you have to do the recovery, right? What is the starting point? So starting point is the checkpointed SCN, last checkpointed SCN that you find in your control file. So from that point onwards, you need to make sure that changes have to be applied from that particular SCN onwards. Now, when I say control file having the checkpointed information, there could be certain exceptional situations where a certain data file is not having the appropriate SCN as well. Maybe the data file had gone offline. Control file is fine. The rest of the data files are fine, but not a particular data file. So that data file header might be lacking the needed checkpointed SCN. So maybe that data file is requiring recovery. Well, that's a different story altogether. But here we are talking about purely an instance recovery. Okay. So in an instance recovery, it will identify that the database has gone up to, let's say, 10,000 SCN, whereas the last checkpoint at SCN had occurred at 9,500. Just imagine, I mean, assume, okay? So from 9,500 SCN to 10,000, you need to start the recovery. Okay. So how does the recovery process starts with a roll forward? In roll forward, what does it do? It starts reading the SCN, the redo entries corresponding to SCNs. In my example, 9,500. So from 9,500 onwards, changes that are there in the redo stream will be recalled in order to reconstruct the transactions. So then it will start recalling them, and it can recall the transaction. And these recall transactions, what would happen? Transactions will be just applied, right? Let's say as an example, maybe during that time, somebody would have done an update on a particular table, right? So the redo might be holding information. What was the previous value? What exactly the location that had been changed? What is the new value? So that piece of information is kind of sufficient for us to rebuild the transaction. Now that update had gone in, but before it got committed, or before maybe would have got committed as well. But however, before it got transferred to the data files, right? Maybe a failure had occurred. So if you want to read it from the redos, redo will give us the old value, the new value, the location. That piece of information is enough to regenerate the transaction. So what Oracle would do is it will talk to the redo streams and try to reconstruct the same transaction and apply it back to the database. Okay. So when you are applying these databases, again, the same theory applies. What is that? The undo that I mentioned you about. Before a block gets changed, you need to have a previous image taken. If this update is to happen, before the update, what had been the proper value, proper block value, and that will be separately kept as a backup of the block. And that will be maintained in the undo segments, right? So when the roll forward phase happens, even the undo table space will start getting activated. It will try to copy the mirror images or the before images of the blocks that are getting changed due to this redo apply. When I say redo apply, it's not redo apply, but through redos, you construct the transaction and apply. And then you keep on applying until it gets to the end of the redo stream. From 9,500 to 10,000, and that is what I said. So up to such time, everything will be rolled forward. So when I say everything, those changes will include both committed and uncommitted as well, right? At the same time, keep in mind, I told you at the beginning, due to what you call, uh, intermittent checkpointing, right? We call it the incremental checkpoint. There could be changes that had already gone into the data files, maybe for a temporary period. Right? Those are not committed blocks also, right? So those may still appear on the data files. Right? So regardless of that, from this point where the last checkpoint had occurred until you come to the end of the redo streams, everything will be rolled forwarded by reconstructing the transactions through redo streams. Right? Hope that is understood. So that's phase number one. So you have everything applied back to the database. And at this particular moment, the database is still not open for the users. I keep that in mind. So during this phase one, roll forward phase, database is not accessible by the users. Now, and it has everything now applied back to the database, and those change, blocks that you have applied changes might have got updated, I mean, changed and committed. Some blocks may not have got updated as well, I mean, committed as well. right? At the same time, I told you about the undo segments, so you have a before image as well in case if you want to undo those. Okay. Now the database will be open for the users. The moment you open the open for the users, then when I say open, why it gets open before it finishes the second, which is the rollback phase, is because Oracle needs to make sure Oracle will basically enable the database to be accessed by the users as fast as possible. Because this instance recovery, I'm saying, right, it may not have got affected the entire database, maybe for few files, few table spaces, right? So it is not going to compromise that time. So that is why it is getting open for the users at that time. Now, when these changes are coming in, when once the row forward is finished, right? The next thing that is going to happen is the second phase, which we call rollback. In rollback, what happens? Now, I told you the entire redo stream from that last checkpoint at SCN had got applied, right? So some of them, it knows that those transactions are not committed. Now it is a time where systems monitor. Now, early also, roll forward phase, it is a systems monitor who will start reconstructing the changes or reconstructing the transactions from the redo stream, the S1 background process, which we came across at the beginning of this presentation, right? And similarly, it will perform the rollback operation as well, where if the blocks during that time had been in flight, meaning changes have happened, but no commit statement was issued, those have to be rolled back because we don't know the state of that transaction. It will try to apply, it will try to do the rollback, right, using SMON at that time. Okay. Now you may wonder, let's say when the rollback operation is in progress, there could be a transaction that are coming, a particular transaction that is coming into one of those tables. Now, because now the database is open for users, right? Users can also write changes to the tables. So when that happens, actually the rollback can be done by the user who's performing that transaction instead of waiting for a small. We don't need to go into that depth, but that can also happen as well. Generally, the task is for the SMO who would be really doing the rollback operation for uncommitted blocks. Now, when you want to roll back, you need to have a before image of the block, right? So we know during the roll forward phase, before images were already created and were kept inside undo segments. So from undo segments, it will replace the change blocks which are not which were not committed. Okay, so that is how it happens, and this rollback will happen in a parallel form in order to make that process fast. And so here the in-flight transactions that were not really committed during the time of the failure, ongoing but not committed during the time of failure, will be marked as terminated. So those transactions will be rejected. And I also told you new transaction can be rolled back without waiting for SMON. So that is the one that I was talking about a while back, meaning it is SMON who's supposed to do the rollback. But if another session wants to do a new session, let's say once the database is open, when a new session wants to do a change to the same one of the tables that are being rolled back, right? Then without waiting for SMON to do that, the session itself can do the rollback on that and start commencing on his new transaction. Okay. So this is actually a complex process, right? So although it is complex, the good thing or the good news is that for instance recovery, we don't need any manual intervention. Right? It's purely, it's entirely automatic, right? We can influence the instance recovery process by setting timelines for the instance recovery to complete. Right? As we know, roll forward phase, the database is inaccessible, right? So therefore, if the database needs to be, or if we have a SLA or service level agreement for our end users, ensuring that the database will be open for users or the application is open for the users by this number of minutes or seconds, then you need to tune your instance recovery as well. So instance recovery tuning is a separate subject. I'm sorry, separate activity, right, which we are not going to discuss here. But it is something that we can do, that we can concentrate as well. So I'll give you a few hints on that as well, probably in the next slide to come. Okay, now this is the summary of what we have already discussed. So here you can see the checkpoint position because, okay, so let me just check the pointer here, pointer to, okay. Yes. So this is the checkpoint position, which I said that everything has been, committed. Sorry, not committed, checkpointed. So this is where we are currently. And at this is the time where the instance recovery gets started after a failure. So it detects that from here to, this is the whole redo stream available. So redo stream will start applying all the changes from this checkpoint position up till the end of the redo stream, right? All the changes will come in, but some of these changes would have got committed already, or maybe in a intermediate state, which are they are all uncommitted ones. So this is phase number one, right? And then in phase number two, you make use of your undo segments in order to roll back what have been not committed. There are about, so the question marks basically indicate the uncommitted changes. So these uncommitted changes will also be applied during the roll forward phase, because that's what I said. Everything will be applied from the last checkpoint to this end. Right? So everything will be applied, but those some of them have to be taken off because there were no commit request sent prior to the failure. So the during this construction time, they also had Oracle had also come up with the undo segments having the previous images of the blocks, and those will be replacing these blocks that are not committed, right? So that is what is going to happen during the rollback phase. So it relies on, Oracle will rely on the undo segments there. Okay. Right. So these are the points that I wanted to highlight in terms of checking your settings for instance recovery. One is the lock checkpoint interval. So you can see the default values I have given as well. So currently it is ignored by default. So lock checkpoint interval determines the number of redo blocks. So since let's say if I have set it to 100, after the last checkpoint, when 100 blocks of redo gets filled, you need to incur a log check. You have to incur a checkpoint. Okay, so that is the understanding here, but default it is ignored. So even if you have set a value like 100 here, if you can recall, a log switch will incur a checkpoint, right? Log switch will incur a checkpoint. So if you have set it to 100, but your log file size, and if you take the block size, total block size, number of blocks in a redo, I'm just assuming, let's say if it is 75. So in 75, the log switch will occur, right? And the checkpoint will occur. So it will not really consider the 100 value that you have specified. So you have to be a bit mindful of values that you are setting here. So it may not really be effective in that case. Okay. Then we also have a log checkpoint timeout. So this basically indicates since the last checkpoint, after how many seconds you need to explicitly incur another checkpoint. So these are all influencing parameters to change the timings of the checkpoint. All right. Okay. And then we also have a parameter called fast start MTTR target, fast start mean time to recover target. This is a SLA that we set on our instance, how fast you want to bring it up. Currently, it is 0, right? And it basically determines how fast you need to overcome the crash recovery, right? So simply speaking, right? Simply speaking, if you have less amount of dirty buffers in your instance at any given time, your crash recovery will be fast, right? But if you have to if you have had lots of dirty buffers in the memory, then the crash recovery would take more time. Okay, so that is what you have to understand. Now, what happens here is that you have this what you call in the $P instance recovery. It's a view that I'm talking about. It has a column called optimal log file size, which you can observe. Okay, so here we identify a time. Okay, for fast start MTTR target. So let's just assume, right, that I want my database instance to do a instance recovery within 100 seconds. So maybe you set a value like 100 seconds for this parameter. And then in order to really make use of it, you need to check the optimal log file size there. Then Oracle will advise you based on the activity that is happening or that is happening at the database front, will tell you or will suggest you of optimal log file size. So what is the relationship between setting this value to 100 and changing the log file size? Again, if you can remember, the log switch that is going to create cause a checkpoint, right? So if your uh, mean time to recover value is high, that means I can delay my log switch activity, right? Because if your log file size is small, then the frequency of log switching would be high. If your log file size is 50 MB, then your log switching time would be fast or faster than that of a log file size of 100 MB, right? So changing the size of the log file, we can influence the instance recovery time. Hope you got that point. So I will just explain it once more. So MTTR target value is basically a time that you give in order to determine how fast you want to complete your instance recovery, right? So more the dirty buffers that you have in your memory, more the time it takes, right? So if you want to reduce the dirty buffers at any given time, then best thing would be to reduce the size of the redo log file. Why? Because we know in each or during each log switch time, a checkpoint is going to occur. So checkpoint will take the dirty buffers into the disk, right? So therefore, if you want to have a very minimum MTTR target value or instance recovery time value or less time, then definitely our log file size has to be small. Similarly, if you can tolerate fairly larger time to complete your instance recovery, then you may be keeping more data in the dirty buffers in the instance before a before a checkpoint occurs. So that can be influenced by a larger redo log file. So if it is larger, then the log switch time will be more. That means your checkpointing time will be delayed. Okay, right. So regardless of the value that you have determined here based on the SLAs that you want, if you have already given the log checkpoint interval, by default it is 1800. So that will overwrite whatever you have set, the whatever the value that you have set here, because this could occur before that, right? So we again a bit careful, and you need to have an understanding of how these parameters can be used in order to come up with the appropriate redo log file size. Not just that, but here we are we are talking about instance recovery. So when you are dealing with the instance recovery, how fast you want to do it, and um, how um, how efficiently you need to tackle this, because the moment you have a higher frequency of checkpointing, that will impact the database. So that's why I told you at the beginning of this session as well. If you have more checkpoints occurring, then it is going to be a big overhead to the database. That's why Oracle is automatically flushing some of its what do you call, dirty buffers to the data files at certain times, because to minimize that impact. Because if the database is idling, that would be the right time to flush these dirty buffers to the disk, even though it's not really a database a checkpoint, right? Um, so intermittently, or increment at an incremental level, these checkpoints will get occurred just to reduce that overhead. So always remember, checkpointing is a big task for the database, so that has to be managed properly. And equally, we have to manage the instance recovery as well, because if that takes a lot of time after instance crash, then that will also impact the end users as well. All right. So I think that basically brings us to the end of this session. The session is over, but of course it is open for questions.
So I have a question.
Yeah.
So suppose like we have three redo groups, and
Right.
the first one is the logwrite is writing for the first group, and the other two groups were in the active status. So it will be the database will be hang, right? Or
Okay.
else,
So I'll show you something here. Since you had that same question regarding the status of the redos, I had one open screen. Let me just see if I can pull that out. Mhm. Okay. Yep. Right. So here you can see this window of mine has three log files. Oh, these are the groups, right? And for your information, it has first change number here and last change, sorry, next change number. Those are indicating from what SCN to what SCN. You have changes recorded in these redo logs, right? Okay, so coming back to your point, so currently when the changes are happening, as of now, it's your current redo log file that will take all these changes in, right? Will track the changes. And you can also see two of my redo log groups are in active status,
yeah,
right? The understanding that you have to have with active status is that, you know, these redo log files, or the content of these redo log files, are still needed for an instance recovery. In the event, as a, in the event if this gets shut down with the bot option, or maybe a instance failure had happened,
yeah,
Oracle will read changes from the current redo log file from that and the two active read log groups that you have here. So basically, as of this example, if something goes wrong right now, Oracle have to read changes from all these three groups. That's the understanding that you have, that you need to have when the status says active. I can take this thing off also. Now, let's say that if you can remember, I told you about the thread
Yeah.
checkpointing. One example is to explicitly issue a checkpoint, right? So if I do alter system checkpoint, okay.
Yeah.
So this basically ensures that as of now, everything is properly synchronized to the database, right? So let's now query the redo log status here, right? So now they have gone into inactive state. So what does this mean now? If something goes
Then.
wrong right now,
Hmm.
right, instance recovery would only be needing to read the current redo log file. It doesn't need to read the inactive ones because these are all properly synchronized in the database.
That means it is written for the database files and the control file settings,
Correct.
right?
Correct.
Okay. So how can't we identify that like before this happens? Because if the two groups are active and the first one is in current status, so
Yep.
if can't we identify, or like if the database will hang, it will be a disaster, right? So can't we really
Mm,
identify it whether this is happening or is
okay.
like
So yeah. So when I say okay, so just because we are seeing the group in an active
because
state
every
doesn't.
time we don't check the redo groups, no, that's it.
Yeah. Yeah, correct. So now the point that I wanted to highlight was you don't need to get worried also over the groups becoming active, because the
Okay.
activeness basically indicate that in case if something goes wrong, we need to read these two groups. Your worry basically comes into play in the event if these active groups are corrupted.
Yeah, that's it.
If they're physically corrupted, then you're in trouble because you won't be able to read them. So that is why we have multiplexing. As of now, we have, yeah, I also have two members here in this group. So I can multiplex. So even if one member fails, I can use a second member to do the recovery,
Okay.
right?
So is it a solution to add another group? Because this means that the groups are, is it enough? Like, does it means the groups are not enough to do the job, or else the
Uh,
what is the issue of this?
not exactly. So why we would need additional groups is because I'll give you one example, right? If you closely monitor your alert file,
Yeah.
sometimes because of the frequency of log switching, right? You may see messages like checkpoint not complete.
Yeah. Yes.
So the idea behind checkpoint not complete means it is aggressively changing the log. It is aggressively doing log switching, but the the checkpoint process is not capable of meeting that meeting that speed of writing them to the data files. Okay.
Okay.
So that
Okay.
could be one of the reasons for you to have more redo log files so that checkpoint will have enough time to write the changes to the data files. All
Okay.
right. But other
So
than
so
that, yeah.
so can, like, is it possible to have like I had the experience in one of our company, like
Hello. Did we lose you?
hello.
San, is it you?
Yeah.
Okay. Yeah. Tell me.
So is it possible to have have 10 groups in a database? Because even Oracle recommend like three groups, right? So is it possible to have 10 groups with 20 members?
Yep. So you can determine. So the upper limit of the redo log groups is specified as a parameter in the control file. So as
Yeah.
long as you are not exceeding that amount, I mean, you can still recreate the control file and change the limit. But
Yeah.
so I mean, it's basically up to the organization to decide how many redo loop groups that you need to have. Again, there is no benchmark figure or optimal
Okay.
figure as such, but as you rightly mentioned, there is a compulsory requirement of two. Right? So you need to have at least two groups, but the number of members that you need to maintain, I mean, how many, what is the multiplexing factor that you're going to use is something that you can decide. But again, you need to understand the moment you have multiple members in a given group. Generally, having
Okay.
two is okay. But what I'm
Okay.
saying is that if it is more than that, I mean, per group having more members, will increase the database wait
IO
event
load.
of
Yeah.
that is log file parallel write. So uh, that indication will come into into play because it has to write to all the members at the same time. So that is log file parallel write. So you can just monitor that as well. So as long as you are on ASM and if you have done you know, proper architecture for ASM, I think with two members you can survive.
Managed.
And
Yeah.
this, yeah, and also
So
about the groups based on the speed and also the size of the redos, because sometimes some people feel like if they go with a larger redo log size, then if
yeah.
something goes wrong in one of the blocks, then your entire file is gone.
Yeah, because
Then the
I
amount of
the radio size, the group size is 3 GB, sir.
okay.
So
Yeah, so you are bound to lose 3 GB up maximum up to 3 GB if the current redo log file is gone, right? So if the current redo log file is gone, then up to maximum of 3 GB you will lose because there is no way
so
that you can recover your current.
so default is it 1 G below 1 GB, or else is there any default size for the
If I'm
redo
not
groups?
mistaken, the default size is 200 MB. Maybe Asiri can confirm it also. I can't exactly
There again,
remember.
that sizing is very crucial thing because the sizing is depending on the transaction levels. I mean, that
Yeah.
means if you that 3 GB might be optimal for that pure database because some databases we have a 5 GB kind of a things, but some databases we might have 1 GB. So that depends on the guy. We have to measure the transaction. What do you call? Transaction ratio. So to calculate the size of that the redo log size is depending on the so many factors. Am I correct, Kayan?
So is it like tuning process, right? Teacher?
Yes, tuning. I mean, optimizing the size of redo logs size.
So sorry, I was on mute. So I was saying before, specifically on a instance recovery angle, then we have this fast start MTTR target, which is currently set to 0. And you can basically determine your optimal log file size through v$ instance recovery. Right. So this has this column called optimal log file size. So if you just do select this one from v$ instance recovery, you can see there is no value as of now because we have not set the fast start MTTR target. But if you set this value, or the system set fast start MTTR target, just give a value like 100, right? And based on the activity that is happening in the database, it will suggest you with a read log file size. So if you want your recovery to finish fast, right? I want this to be done in 50 seconds. I think this is in 6 seconds, right? And then you can see the log file size going down because then log switching will be faster. Again, the value that it is suggesting is based on the current workload that you have in the database. In my case, there is nothing happening right now. So these values may not be the optimal value. So you have to run this during your peak time and figure out what's the right size for your redos. At the same time, it all depends on the fast start MTTR target that you set. So if you feel that your SLA is 100 seconds, then you can set it to 100 seconds. So it all depends on what your business would like to have.
Okay, sir.
Yeah.
I
Thank
think
you, sir. Thank you, Asif, sir.
Yeah, no
Yeah.
problem.
So within this session, Gayan has mentioned so many weight events. So the actually those events need to be in your mind actually, because otherwise you can't do performance tuning kind of a thing. So log file switches, log sync, multiple parallel, the redo log parallel writes, and all that. You have to read all those contents separately. I mean, within this session, we can describe what is this, but in depth, you have to read about that weight events. Otherwise, you can't get the clear idea about the entire thing.
Okay, sir.
Yeah,
So,
so I think
Thank you, sir.
good set of questions were asked. It's good to have a bit of interaction. Otherwise, it will be always one way. We don't want to happen that.
any question? Other
Yeah, so I think another thing that we have to tell is that the although we talk about fundamentals, some of them may be a little difficult to grasp. So I think it is important to go through the recorded sessions several times as well.
Yes.
In getting to know the concept well.
Other than that, there are so many YouTube videos available for instance recovery and all that, because you can, if you can't, if you want deep dive against that instance recovery, you can follow those videos also.
That's right. So that's also another thing, and also Asiri, a good thing about live session is that you can ask questions then and there. Sometimes when you listen to a recorded video and you come up with a question and you may not get an answer right from the recorded video.
Yes.
So it's always important to participate as well and then raise your questions then and there to clear your doubts.
Sir, is it possible to have a practical session, like if how to do a recovery sessions, and if a database hang, what shall we do likewise?
Oh, okay. I think I will put that forward to Asiri.
Yeah, we'll do that, because I have to, because we'll do that, because it is not, not within this week. So this week I might be very busy because of this pandemic situation. So apart from these things, I'm really engaging with the community things. So tomorrow and day after tomorrow, I am not at the office, and I'm going for the that participate in some activities. We are planning to help the people who are suffering this pandemic. So I will ask somebody to do practical sessions within this week, not from my side. So yeah, we'll do in next week or after that. So Sajivan, are you preparing for your sessions? Sajivan, you can
Hello, sir.
you can explain. I mean, you can describe what you are going to do, and you can present what you have done. So again,
Asiri,
yeah.
Yes, I might have to leave.
Recording might be stops, right?
Yeah, let's stop the recording.
Yeah. Avindu,
Yeah.
you can
Sir,
stop recording.
Yeah. Sajun, good luck. Asiri, I'm sorry, I have to leave. I have to.
Yes, definitely. And thank you
Yeah.
for your time.